But they don't follow that. They don't follow more record the class we are buying, but you can be following. But
send this to me.
Send this, my buying you get version that you get. When you're putting your show, but no while I will find a way around it. So agent continue so that we can save that.
Okay, John, what me send you?
I send it, but I want to explain before you but let me just quickly rush over it. A thermodynamic systems is a matter or a region of matter under consideration. You see, the key fact there is that we are studying that area.
Okay, yeah.
For the purpose we are achieving the you understand? There is something we want to achieve in that area. Otherwise, the main thing, the babara fún wa, aṣọ di iṣẹ́. So in that area, aṣọ di iṣẹ́ that consider is what we call a thermodynamic system. Whatsoever that is inside that thing, whatsoever any matter, solid, liquid, gaseous that is inside that place is called a system. So there is always this boundary, there is this wall, there is this location, BOD, to the system. The boundary. Nǹkan tó wà ní outside the system, outside boundary, tí o sì no system, on la pè surroundings.
Surroundings, yeah.
Now, there is a system that doesn't allow mass or matter to cross and goes out at their own.
Which is the closed one.
Is a closed system.
Closed, yes.
While open system is the one that allow mass to cross this boundary, to goes in and comes out. That's what we call an open system. Now, if I go back to definition thermodynamic system, I'm asking Kakambe, which is under consideration. Killer and consider thermodynamic properties. And consider temperature, pressure, volume, enthalpy, entropy, and internal energy.
Okay, yes.
These are
consider.
Then if I have source I want measure temperature, I measure pressure. I feel we going to change in What do you mean, sir?
Yeah, me.
Let me still bring it down. Mo fẹ́ kẹ́ understand that. So, ìdí tá a fi pè ní system, ṣe ń gbọ́ mi, ó ní pé temperature ọbẹ̀ wá jẹ wá lógún báyìí.
A fẹ́
mọ̀. Pressure ọbẹ̀ jẹ wá lógún. A fẹ́ mọ̀. Internal energy ẹ̀ jẹ wá lógún. A fẹ́ mọ̀. Entropy ẹ̀ jẹ wá lógún. A fẹ́ mọ̀. Ṣé understand me báyìí?
Okay.
So, ìdí ẹ̀ nìyẹn. So ibi tá a bá wá tí ó bá sí under consideration tá a fẹ́ wọn kankan tó wà níbẹ̀, it's not a system. Ṣé understand báyìí? So area that we carved out, the boundary might be visible, it might not be visible. Ṣé understand? But we now started measuring the properties of that place. Ṣé understand? Is what we call a thermodynamic system. Now, our properties tí mo sọ ìpá measure yìí, wọ́n là ń pè ní thermodynamic properties.
Properties, okay.
You understand? Which are 6.
Be specific.
6.
Volume.
6 ní gbogbo wọn. You understand?
6 ní gbogbo wọn. Okay.
Ẹ̀bùn ẹ̀ má ti di àlọ́ sí specific meeting. Ẹ máa mọ̀ tún mọ̀ ní specific later. I will go there later. So number 1 is temperature. Number 2 is pressure. Number 3 is volume. Number 4 is entropy. Number 5 is internal energy. And number 6 is something called enthalpy.
Enthalpy, yeah. Okay.
So these are 6 of them. Now,
6 of them. Okay.
Thermodynamic state. Thermodynamic state is when these two properties that's is known.
Okay.
Property me ìkan méjì inú àwọn property mẹ́fẹ̀ẹ̀fà tá a sọ̀rọ̀ pa èyí.
Okay.
You understand? Tá bá fi lè mọ̀ méjì inú ẹ̀.
Okay.
We say we have established a thermodynamic state.
Oh, At least méjì àbí méjì lọ.
At least méjì màá sì ṣàlàyé ẹ má wọlé ẹ ṣáà follow.
Okay.
So anybody that is giving you a thermodynamic problem is giving you two properties to divide a state for you. But ẹ ṣáà máa follow me. So because there is something called two property rule. Ó sọ pé tẹ́ bá fi lè mọ thermodynamic property méjì ẹ lè mọ mẹ́rin tó ṣẹ́kù. Equation wà tó link méjì yẹn mọ mẹ́rin tó ṣẹ́kù. Ṣé ti understand me right?
Okay.
Now, so ẹja àjà máa follow ẹ lọ. So a state is divided by two properties, two distinguished properties. So ẹ jẹ́ fi example tí mo lè fi ṣàlàyé what a state is for you. Bí kéèyàn sọ pé èèyàn ti dé Ọ̀ṣun state. Ṣé understand?
Okay.
So mo wá easier way but ẹ má worry mo still find a easier way to get to it. But in that state, two properties are distinguished. One, they change one.
Okay.
So
constant.
Constant. So that place that we establish is what we call a thermodynamic state. For example, omi tá a gbé sínú pot tá a dé pa, ṣé mo pé ó wà ní room temperature?
Yeah.
Room temperature, let's say 27 degrees Celsius, abi?
Yeah.
Ó dẹ̀ wà ní under atmospheric pressure 1.100325 bar.
Okay.
You understand? So since that is not the sort temperature at pressure fún wa, yẹn pẹ́ tí sọ property méjì fún wa.
Yes.
That is the state at which that property, that matter tó jó mi, tí pot jẹ́ boundary, táwọn nǹkan tó wà ń tà jẹ́ surroundings. Wọ́n ti sọ property ẹ̀ fún wa. Wọ́n ti sọ state tó wà fún wa. Ṣé you understand me, sir?
Okay.
Because wọ́n fún wa ní temperature, wọ́n dẹ̀ fún wa ní kíni pressure.
Okay.
So they giving us the two properties. So paraventure wọ́n á bẹ̀rẹ̀ sí ní gbé kaná àbí omi ẹ̀ wá move láti 0, 1, 2 di 100 tó bẹ̀rẹ̀ sí ní boil.
Yes.
So at 100 degrees Celsius atmospheric pressure again, another state is established.
At 100 degree, okay. No, at 100 degree, yeah. Okay, pressure, yes. What is my pressure? It's about measuring.
Atmospheric pressure, not Lucimaje. Now, because normally in thermodynamics class, I supposed to explain what the temperature is, what the pressure is, what is enthalpy, what is entropy. So I will take my time now to go over them. Now, maybe peradventure, if you are able to do them finish tonight and we do state, we do process, we just end this like this for tonight. So temperature is actually called the degree of hotness or coldness of a body.
Yes, correct.
Of hotness or coldness of a body. What temperature? Temperature is totally different from heat energy. There are two different things. Energy is measured in joules, temperature is measured in Kelvin, Celsius, Fahrenheit, Rankine.
Yeah.
So these are units of temperatures. So, like one of the questions the man asked me to do is to convert it from Fahrenheit he gave to us to something called Celsius. So, question to set in when you can convert it, I need to convert 70 degrees Fahrenheit. That was the question.
Oh, okay.
So,
I'm a convert to
Kelvin. Most of the calculation you will be doing in thermodynamics is done in Kelvin. And I will explain why.
Kelvin. Oh.
No. There is something we believe in kinetics theory of matter, that matter is in constant motion. That the second part of that theory says that the average kinetic energy of the matter is directly proportional to its temperature.
Okay.
Now, I pray that God will give us understanding that you understand the both and it's mobile solid.
Okay.
Sharing molecule solids, they were together. Only one affiliation. Shall the mobile drinking in this life? All one lock because it's a solid, they are together. So, because the distance, there is no intermolecular distance line, whatever will under microscope. Now, we form solids.
Okay.
Ṣé understand me? Ẹ jẹ́ consider ice block. Ẹ wá bẹ̀rẹ̀ sí ní gbé ice block kaná, ẹ bẹ̀rẹ̀ sí ní warm ẹ̀ pẹ̀lú temperature. Kí lẹ rò pé máa ṣẹlẹ̀? Bond yẹn máa tú. Wọ́n máa ṣàn sílẹ̀. Àwọn dàbí ẹni tó dànù. Ṣé understand ice block pẹ̀lú àwọn dàpọ̀ dànù. Ṣé understand? So bond between them ó wà break nítorí energy tẹ̀ fi sínú wọn and they are now moving more faster. Àbí? Now number one, the gas tẹ̀ tún gbé kaná tó di steam. At that place more tiẹ̀ wà ní distance kankan láàrin ara wọn mọ́. That means bí molecule yìí ṣe lè move ó wà tied sí temperature. Kò sí èyí sir. Hello sir.
Okay. Which means the faster will be increasing temperature, the faster the
molecules moves. Ṣé understand sir? Now, ó mi wí pé bí mo ṣe mú kíní ìdání sir, ó mi pé there is still small movement nínú molecule airpod yìí.
Okay.
But àwọn small movement yẹn torí pé wọ́n sì wà papọ̀, movement yẹn ò le tó tẹ̀wọ̀n, but abá bẹ̀rẹ̀ sí ní gbé kaná tá a gbé síbi iná tó high gan, ó máa yọ.
Yeah.
Ṣé understand? Because now
break bond there.
Break bond there, ó wá lè move more. Àwọn tá a so wọ́n pọ̀ pọ̀ báyìí, tẹ wá break bond wọn, so that means they can move more.
Yeah.
Now it now means that every solid is moving. Ṣùgbọ́n movement wọn ò pọ̀ torí temperature yẹn ò sufficient láti break bond wọn.
Yeah.
Ṣé ń gbọ́ mi báyìí? Now, there is now a temperature called absolute zero temperature. Absolute zero temperature. Which means that temperature tí molecule ti move rárá.
Absolute.
Ṣé you understand the concept of absolute zero ti wá báyìí? At absolute temperature, it is expected that molecules does not move at all. Ṣé bí lè ṣe ra wà kékeré yìí torí wọ́n sì ní absolute zero, wọ́n sì ń vibrate wọ́n ẹ̀ lè rí àfi tẹ́ bá fi microscope wò. Energy
absolute zero, yeah, which means the lowest.
At that, everything is on rest. All molecules are on rest.
On rest.
That's
absolute.
Absolute zero temperature, and is considered to be minus 273 0 degrees Kelvin.
0 degrees Kelvin or negative 270
Celsius. You understand that?
Yeah.
Ibi tí concept ká máa lo Kelvin for calculation ní thermodynamics ti wá nìyẹn.
Okay.
Because Kelvin ló fún wa ní absolute zero. You understand? Àwọn other standard scales, they were not giving us zero. This class is not actually a physics class. No, that's often you define Kelvin, define Celsius, define Fahrenheit. But got that money pé mo kálukú ṣe develop scale here. But if another time come any more chances, I will be able to explain. So it's fundamentally for thermodynamics, we will always be using Kelvin to solve our problem. So, and that's so there are different types of thermometer, there is different type of temperature, but for the concept of thermodynamics, I think that is fine. That is right. So we can move to something called pressure.
Pressure. Yeah.
Now, so before I explain what the pressure is, let's start from here. Pressure is actually force over area. The amount of force expressed over a known area, perpendicular area. That's what we call pressure. You pressurize me, you pressure me. It means that you are pressing me, you are pushing me, or apply force in my certain area.
Don't pressurize me. Don't apply force on me.
So don't pressurize me. Don't put force on me.
So which means a area for force.
It bends, sir. So that's what it's doing. Now, I just example about an example. See, obìnrin bá wọ slippers, wọ́n lè gba ibìkan kọjá ẹni mọ́, but wọ́n bá wọ àwọn stiletto tẹ́nu ẹ̀rí ṣómṣóm báyìí.
Àwọn early bottom.
Ó máa lù ú lọ. Ṣé mo reason? The pressure is high because it's the same force but small area.
Small area, yeah.
Ṣé you understand the concept? Ìdí tí ọ̀bẹ tó fi lè gé ọsàn tó fi lè gé nǹkan ni pé ẹnu ọ̀bẹ kéré ààrẹ máa sọ pé lọ́pọ̀ bẹ̀ yìí kọ́ inú ẹ̀ lè kéré kí ó lè small area.
Yeah.
Understand? And there is a sword that Japanese people used to use tó lè gé èèyàn sí méjì. Sword yẹn tínrín pa. So that
torí pé area
yẹn gbọ́dọ̀ kéré, so with small force greater thing will be done.
Okay, ó ti lè pé tí force bá tóbi
tí
area máa kéré.
So pressure will be high.
Okay, pressure will be no tí force yẹn bá tóbi.
Yes.
Pressure máa high àbí.
Tí area tún wá kéré ṣe o pe is force over area.
Yes.
So that's what we mean by pressure. Now again, pressure is compressive in nature. Pressure is always compressive in nature. This is pressure. I'm applying this force over this area of my hand and I'm pressurizing the second hand. Now, very interesting. We are going to a very interesting part. Sorry. All right, sir. Let's continue, sir.
Okay.
So, the earth, ayé tá à ń gbé yìí, you understand? Ṣé o pé orí ayé la wà? Kì í ṣe inú ayé.
What do you mean by that?
Earth is spherical. Earth is actually geroid.
Ṣèbí ilé la wà.
Nínú ẹ̀kọ́ la wà, sir.
Ìta la wà. Àti máa ṣubú.
Màá ṣàlàyé gbogbo yẹn later. Ṣẹ́rí, nǹkan tí mo fẹ́ ṣàlàyé ni, it takes me a lot of years before I can understand it. Bẹ́ẹ̀ náà ṣe máa rò pé inú ayé la wà, ṣe pé Yorùbá, Bible, in the earth, in the kìnìkan inú ayé kọ́ la wà. Orí ayé la wà, on the earth. Ṣẹ́rí ẹ wọlé mi tẹ́ wà báyìí. Ẹ wọlé. Ilẹ̀ tẹ́ ń wo yẹn ní earth. Ẹ̀yin lẹ jókòó lórí earth. Ó ti yé báyìí. Ẹ bá wọ̀nyí máa prove ẹ̀ fún yín gbogbo ọ̀nà. Tẹ́ bá launch rocket, ó yẹ kó lu ayé jáde. Àbí?
Bẹ́ẹ̀ ni lóòótọ́, ó yẹ kó lu já lóòótọ́ ni.
Tó lu.
Kò lu já, but kí ló wá mú wa dúró?
Nǹkan tá ń pè ní gravity.
Okay, gravity nìyẹn. Ló gbé wa dúró.
So it's a very serious concept ẹ ní láti understand. So káláyé ni.
Ṣé máa ń sọ náà máa ń sọ because èdè ìlú mi kan fi ń sọ mi nǹkan tí wọ́n sọ gan tí a máa accept ẹ̀ bẹ́ẹ̀ náà ni. So gravity ló ṣe báyìí. Gravity ló ṣe báyìí. Gravity ò sí ní Bíbélì. Okay.
More details. So ká ní ayé nìyí ní power bank ọwọ́ mi àwọn ibi tá a wà ní. So kì í ṣe inú ayé là ní lórí ayé là wà sá. Now ṣé rí ayé
ṣàtúráǹdì ẹ̀ ni.
Gbogbo bí la wà gbogbo bí ẹni pé mọ́sàndà ní gbogbo bí làwọn èèyàn wà gbogbo bí.
Ráǹdì
ẹ̀ gbogbo ara ẹ̀ báyìí bẹ́ẹ̀ la wà. Later in the day, we might just do a bit of geography to explain to you that Earth is actually geoid, something that looks like a circle, nothing that looks like a sphere.
Spherical.
Yeah, it's spherical, but it's not complete spherical. Full level and secondary advanced of spherical. In advanced level, Earth is geoid. So
geoid.
G-E-O-D. Geoid.
Yeah.
Geoid. So, but here again, concern me, it's not a problem to a thermodynamics person. So, ayé yẹn, Ọlọ́run wá fi sínú nǹkan kan, bí ẹni pé ẹ fi ayé sínú capsule. Ṣé ẹ wo ayé tí mo mú dání báyìí? Bí ẹni nǹkan tó wá láǹdì ẹ̀ báyìí, ó wá jẹ́ some
bí jelly something.
Ó wá jẹ́ some kind of thing called air. Air yẹn lọ́lọ́run fi wo ayé báyìí.
Atẹ́gùn àbí?
Atẹ́gùn bẹ́ẹ̀ ni. Ṣé rí ẹ̀yìn náà wá ń pè ní atmosphere? Ẹ wo mi báyìí. Ẹ wo bí mo ṣe fọwọ́ gbá kínní. Ní tí mo fọwọ́ gbá ní atmosphere. Gbogbo kínní báyìí. Eléyìí báyìí. Everywhere báyìí. Atmosphere. Atmosphere yẹn lọ́lọ́run fi oxygen sí, lọ́lọ́run fi nitrogen sí. Tá a fi ń ní nǹkan mi. ṣé ẹ̀ ń gbọ́ mi báyìí?
Yeah.
So mo lọ sí concept ibi gangan ló ti padà wá padà tán mọ́ thermodynamics. So nǹkan tẹ́ ẹ fi sórí ayé báyìí, so air tó wà lórí ayé yóò máa try láti press ìkíní yẹn. Ṣé understand? A máa press lighter yìí, wọn ló wà lórí ayé yìí. Àwọn air tó wà lára díẹ̀ máa press lighter yìí. Ṣé understand me, sir? Especially àwọn tó wà directly orí lighter máa press lighter. So tí mo ṣe wà yìí, air tó wà lórí mi ó ń press yìí. Níbi tẹ́yìn náà wà lọ́hùn, air tó wà lórí yín ó ṣe kí ni? Ó ń press yìí. Ṣé understand? Feel ẹ̀, ẹ má worry, mo ti tẹ́tẹ́ kẹ́ feel ẹ̀. Mo máa sọ ìgbà tẹ́ bá fẹ́ feel ẹ̀, máa sọ bẹ́ẹ̀ ṣe lè feel ẹ̀. Ṣé understand? So pressure yẹn attach tó ń attach sórí yín. Ṣé understand? Ó là ń pè ní atmospheric pressure.
Pressure tí
tó fi ń press yín sórí ayé. Ṣé àpò bí ẹni bí wọ́n di ẹrù. Ẹni bí wọ́n di ẹrù yẹ̀ lébi lórí báyìí. Ó wá press yín. Torí pé gbogbo tí a wà yìí wà gbogbo. So pressure tí yẹn tí atmosphere tó ń exact lórí wa, wọn náà ń pè ní atmospheric pressure. Ṣé understand that? Which is the amount of pressure the earth, the atmosphere is exerting on everything on the surface of the earth. So pressure yẹn la evaluate to be 1.01325 times 10 raised to the power 5 Newton per meter square.
That's the atmosphere,
atmospheric pressure. She understand that? So, but what
about 760 mm?
760 millimeter mercury is also atmospheric.
Yes, conversion.
Unit pressure. Unit pressure.
So the same thing, the same value.
The same value. So, because but limited 760 mmHg is most likely when you are considering pressure in liquid. Yes, I will explain.
What about bar?
Bar is Newton. 1 bar is equals to 10 raised to the power 5 Newton per meter square. She understand me, right? So the short atmospheric pressure is actually 1.01325 bar.
Okay.
She understand. So ìgbà tí mo sọ pé mi tó wà nínú port lẹ́ẹ̀kan tí mo consider a system tí mo wá fún yín ní pressure tó wà, mo fún yín ní atmospheric pressure because atmospheric pressure ló ń press omi tó wà ní port yẹn.
Ló ń press yẹn.
Ó yàtọ̀ sígbà tẹ́ bá fẹ́ ọmọ ìdè lórí tẹ́ wá gbókúta sí, pressure will be high.
Okay.
She understand that because you are now exerting more force on it. So that's pressure increasing. So now there are 3 types of pressure.
3 types.
Yes, sir. So we have one called the gauge pressure. The gauge pressure, atmospheric pressure, and
what?
Gauge pressure, atmospheric pressure, and absolute pressure.
Absolute, yes. Absolute.
Yes. Yes. Yes.
My pay attention. See, yes. You know, say video. Say WhatsApp.
Send this.
WhatsApp, abi.
Now send this. Now send this because WhatsApp will really level quantity. You understand? So I have to send
email.
You email no need, but I send this in YouTube. I can't download them.
Okay.
So let's go.
Okay.
So we have gauge pressure, and we have atmospheric pressure. So it says that nobody is feeling absolute atmospheric pressures. I don't feel it. So that one you can so what one understand? So if need pressurize that means mo join here pẹ̀lú pressure láti pressurize you.
Okay.
So nǹkan tẹ́ máa feel nobody yìí kì í ṣe ẹyọkan mọ́. bí ẹni pé àkórajọpọ̀ èmi àti absolute àti atmospheric. So tẹ́ bá join atmospheric àti gauge papọ̀, you understand? Òun ló máa fún yín ní the total pressure that system is under.
Okay, only P yẹn, only P.
Only P absolute. Absolute.
Okay, P absolute.
P absolute.
Okay.
So but P gauge only in tí wọ́n add mọ́ atmospheric tán fi ń press yín. So wọ́n máa fi sọ fún yín pé
P what? P kí ló pè nísìn?
P gauge. P gauge.
Okay, P gauge. Okay,
P gauge ni ìta add mọ́. P absolute only combination atmospheric. Ṣé naturally atmospheric wọ́n pressurize wa.
Yeah.
But tá a bá tún wá gauge ẹ̀ mọ́, tá a tún wá di pressure mọ́ fúnra wa, méjèèjì làwa máa hàt lórí ẹnìkan. Ìyẹn làwa máa pè ní absolute pressure.
Absolute, okay.
So ẹ jẹ́ kí n fún yín example. Ẹ máa ní ẹ bá mi gauge táyà mi.
Yes.
Organize ẹ bá mi gauge táyà mi.
Yeah.
So kí n sì pé increase the pressure. Yes, mo mọ̀ pé pressure kan wà atmospheric tó normal. But ẹ bá mi increase the pressure. Ẹ add mọ́.
Only gauge yẹn.
Gauge yẹn. So tẹ́ bá wá combine gauge àti atmospheric, mo ló wá máa fún yín ní.
Tó wà mẹ́tẹ̀lẹ̀. Àwọn afáàní ìlò absolute.
Ó wá fún absolute pressure. Tí kí ni àwọn ìyàgbọ́. Ṣé ti understand báyìí?
Okay.
That is pressure.
Clear. Yes.
So we have this pressure in different units, torselli, bar. So as an engineer student also, you're supposed to know conversion between one of them to another. Cell system, millimeter mercury, inches mercury, bar, torselli. Pressure has a lot of Newton per meter, Pascal.
Yeah, PSI.
Yes, you are correct, PSI. Like atmospheric pressure, which is 10325 Newton per meter squared, it is 14.7 psi.
Yes, 14.7. Yes, 14.9.
So when we begin to learn all this, it's not really different units because different engineers, different scientists, different people have worked on it, and everybody come up with their units. And the fact that countries different from countries, US will say this is my standard, and Europe will say this is our standard. They are still fighting their battles. The God will see them too. So that's where we are. So what you explain in pressure. So we should go to the next property, which is what? Volume. Volume is just the quantity of a matter in the body.
Volume.
So that's volume.
Yes.
But there is something called specific volume. Please, for the sake of just spare me that one, I will explain it later some other day. Everyone that has specific volume, is just volume divided by mass.
Mass, yes.
But we'll go into more details of it when I'm explaining the intrinsic and extrinsic properties. We'll get to know that one. But we might not be able to do it tonight because this thing is getting interesting more and more.
Honestly, I want to continue to share.
And it's very interesting. Very, very interesting. Just go through. You see that it will just be open. You will not even find it difficult at all.
Yes.
So let's move on. So volume is just the quantity of matter which is in centimeter cube, meter cube, or something of that nature. That's volume. Let's leave that. That's very simple. Then internal energy. Show look on internal energy. Now, let me explain internal energy.
Okay.
There's a problem in thermodynamics. And it's because energy can neither be created nor destroyed. For somebody that just studies thermodynamics at surface, will not be able to explain this now. I want to explain.
Okay.
Now, let's assume we know money to one.
Okay.
Just stand. Let's assume we know money to one. Like, let's use dollars now. Money dollars to one. Who are for $100? Just stand. Who are more? ó wá gba $50 lọ́wọ́ yín.
Okay, out of 100, àbí?
Out of 100 tí mo fún yín. Bọ́ mi ò mọ iye tẹ́ ẹ ní lọ́wọ́.
Tẹ́lẹ̀tẹ́lẹ̀,
initially, but nǹkan tí mo mọ̀ ni wípé wọ̀só yẹ iye tẹ́ ẹ ní lọ́wọ́ ó ti lé by 50.
Yes.
Ṣé ti understand mi right? Mo fún yín ní ẹja tún take example mo fún yín $100. Ẹ wá ní urgent need kan ná $300 sí. Bọ́ mi ò sì tí ì mọ iye tẹ́ ẹ ní lọ́wọ́ náà. But nǹkan tí mo mọ̀ ni wípé ní iye wọ̀só yẹ bá iye tẹ́ ẹ bá ní lọ́wọ́ tẹ́lẹ̀tẹ́lẹ̀ ó gbọ́dọ̀ ti dín $200.
Yes.
Ṣé ti understand mi?
Yes.
So the intrinsic energy the body possess, nobody can evaluate it.
Nobody can evaluate it.
Okay,
nobody can know it.
Irú energy tó wà nínú ayé ní báyìí tó wà nínú ọkùnrin tàbí jọ sọ̀rọ̀ kò sẹ́ni tó kò sí mẹ́ta tẹ́lẹ̀ fi wọn. Ṣé understand mi báyìí?
Bẹ̀ẹ̀ tó wà ń bẹ̀.
Mẹ́ta lè sọ ní pé tí mo bá bẹ̀rẹ̀ sí ní observe yín as a system mo lè wo iye energy tẹ́ ẹ ti gbà àti iye energy tẹ́ ẹ ti ná síta. Màá wá lè sọ pé nínú energy tẹ́ ẹ ní nínú ó dín sí ni àbò lé sí.
Àbò lé sí torí pé nínú títà yẹn ó clear àwọn tí mo gbà sí. Ó ṣe calculate.
Àwọn tẹ́ ẹ gbà sí àwọn nǹkan tẹ́ ẹ yọ sí ó ṣe calculate but àwọn nǹkan tó wà ní gangan kò ṣe calculate. So energy tẹ́ ẹ ní nínú ara yín that a body process physically is what we call internal energy tó ní nínú.
Ìtúwà nínú tí ò ṣe àkáǹtì fún.
Tí ò ṣe àkáǹtì fún. Kò ṣe àkáǹtì fún. Títí tẹ́ fi máa parí thermodynamics láyé ẹ lè àkáǹtì fún. The only thing tẹ́ lè sọ ní pé internal energy ẹ ti increase or internal energy ẹ ti decrease.
Tó hard sí.
Wọ́n reduce sí. Based lórí nǹkan tó undergo omi tẹ́ gbé kaná tẹ́ bẹ̀rẹ̀ sí ní fún ní heat energy. Nǹkan tẹ́ lè sọ ní pé heat energy tẹ́ hard sínú ẹ̀ ó ti máa jẹ́ kí internal energy ẹ̀ increase by the amount of heat energy tẹ́ hard sí. Ṣé ti understand? But kí ni total energy ẹ̀ nobody mọ̀ kò sẹ́ni tó mọ̀. The only thing tá a kàn mọ̀ ni pé internal energy increase àbò decrease. Ṣé ti understand ní ìgbà kan? It's represented by the symbol U and it's represented by the symbol U. And it has a unit as joules or kilojoules. So why if you have specific internal energies, when internal energy is divided by mass, is specific, specific is divided by mass. So can we make progress? Huh?
Yeah.
So what you explain internal energy like that. So let's go to something called entropy. Entropy.
Okay.
Entropy. So I have a very sweet way of explaining entropy to people. Entropy is defined as the degree of disorderliness of a system. Is the degree of disorderliness of a system. So I explain it. Then we just move out of it. It's represented by symbol S.
Okay.
So let's move, sir. Okay. Let's take an example. I clean this whole room. Everything is shiny. That's what people clean the Google, right? Everything is shiny. More dust, everything is nice. Mo wá tinú yàrá ìpa mo wá lọ fún oṣù mẹ́ta. Ìgbà tí máa padà dé kí ni màá bá sà? Ṣé máa kan tí yẹn túmọ̀ sí sà? Ó túmọ̀ sí pé lẹ́yìn ẹ̀kan kò fọwọ́ kan sísítẹ̀mù gan yóò bàjẹ́ lọ́wọ́ rẹ̀. Nǹkan tó túmọ̀ sí ni pé lẹ́yìn ò fọwọ́ kan sísítẹ̀mù lẹ́yìn ẹ̀kan ò débẹ̀ yóò bàjẹ́ lọ́wọ́ rẹ̀. Ṣé nǹkan tá a ṣàlàyé ní ìsìnkú ẹ̀ tí n bá clean gbogbo yàrá ẹ̀?
Yeah.
Máa dẹ̀ kàn tí patẹ́nì yẹn kan wọlé ìgbà tá a bá fi máa dé dọ́ọ̀sì tí máa débẹ̀ lọ fúnra rẹ̀. It's now so you need to explain what entropy is for you, that it is the degree of disorderliness of the system. So it means that system naturally we have problem. Even when nobody touches.
Okay.
I will just advance a bit more than definition. Then maybe later in the day we'll explain. We'll see entropy in real sense. So now it seems to me that entropy will definitely be generated,
Okay.
even for a system that is a closed system. So check in one rule of entropy for you, sir.
Okay.
Entropy of a closed system never decreases.
Of a closed system.
Never decreases. Tẹ́ bá understand the explanation mi nísìnyí, ṣé ẹ pé yàrá tá a ti pa is a closed system.
Yeah.
But síbẹ̀síbẹ̀ entropy ẹ̀ disorderliness ẹ̀ ó increase. Tẹ́ bá wá lóṣù mẹ́ta àbí tẹ́ bá wá lóṣù mẹ́ta bó ṣe máa dọ̀tí kọ́ ni tẹ́ bá wá lọ́dún mẹ́ta yóò tún dọ̀tí jù bẹ́ẹ̀ lọ.
Yes.
So that means the entropy of the disorderliness in a closed system will never go down.
Never go down.
It will always be increasing. It will always be increasing. Yóò máa bàjẹ́ sí i.
Oh yeah, paper close here. Yeah.
Close. Ẹ wá já consider open system. Táwọn èèyàn ń wọ bàtà wọlé tán wọ bàtà jáde.
Ìyẹn máa worst gan.
Ìyẹn máa worst gan. Thank you, sir. So mo ti explain the entropy in closed system and open system like that. It's a very interesting thing in thermodynamics. And this entropy we have internal entropy and external entropy. But along the line we will explain. Ṣẹ́yìn torí pé bí àwọn gas àwọn kan tá à ń study bọ́n ṣe ń fẹ̀gbẹ́ nura wọn friction ṣẹlẹ̀ láàrin wọn, so there will be disorderliness. So that's what causes it. So let's leave entropy like that. Why specific entropy is entropy divided by mass. Abi? Then the last one, enthalpy. Enthalpy. E-N-T-H-A-L-P-Y. Enthalpy.
Yeah.
Enthalpy. Now, ilẹ̀kùn tí ó wà wájú táwọn owó yìí sá, ẹ imagine ilẹ̀kùn tí mo bá fọwọ́ gba báyìí bí ṣe àwọn kò ní ṣe. But tí mo bá lọ sẹ́yìn tí mo jì nípa gbà tí mọ́tò bá wà ní tó yẹ̀jẹ̀ fẹ́ start tó bá gbáyìn àti tó bá gbáyìn on speed gẹ́gẹ́ ṣe same thing same mọ́tò. Is it not true, sir?
Yeah.
Ṣé ẹ̀ ń gbọ́ mi sọ̀rọ̀?
Mo gbọ́.
Tí mọ́tò bá gbáyìn tó yẹ̀jẹ̀ fẹ́ start tí mọ́tò yẹ̀jẹ̀ fẹ́ gbéra ó yàtọ̀ sí tó bá gbáyìn on speed.
Ó yàtọ̀.
So nǹkan tí ibi tí enthalpy ti wá nìyẹn. So enthalpy is internal energy plus flow energy.
Plus flow energy. Flow energy and movement.
Ó ní movement tó gbé wá. So ẹ lè rí enthalpy nínú closed system. Tí nǹkan tí máa sọ tó bá lè yí I will be very happy. Ẹ lè rí enthalpy nínú closed system nítorí kò sí flow. Mass is not moving. So enthalpy enthalpy open system la so control volume.
Open system enthalpy.
Because it's a combination of internal energy plus flow energy.
Plus flow energy. Yes.
So as see what I share with you.
Flow
gbọ́dọ̀ wà ńbẹ̀ because
which is movement.
That's
which is matter.
Which is matter, moving in and moving out. I still believe so much that the way God give me the understanding of this thing is always amazing. To me, it's always amazing. Seriously. So
yes, that's true.
It's so.
Professor, no take the time to explain by me.
Yeah, he's not a professor. It's just God. So thermodynamics as at that time, I really don't have problem. But iṣẹ́ ti pọ̀ jù lọ́wọ́ mi like. Iṣẹ́ ti pọ̀ jù. In short, a lọ ṣe prayer work na dé mo bẹ̀rẹ̀ kọ́ yìí. Nígbà láti rìn lálẹ́ yìí, we are just praying that the land should be open, that God will have his way. And I just came back, I did this. Mo lè ti lọ ṣòṣogbo láàárọ̀ yìí, mo ti lọ hold the seminar kan bí àwọn ọmọ sọ fún mi mo fẹ́ lọ hold the seminar kan. Tẹ̀lé seminar yìí mo káwọn ọmọ school. Mo lọ káwọn ọmọ school. Mo dẹ̀ ṣe fast náà mo kàn délé mo kàn break. Mo wá sí church àwa ṣe prayer work. A ṣe prayer work kan wá sí ìpè tí mo fẹ́ wá sùn. And here, this is still after 1. And but eventually there's still one more thing to do before I will now speak. And tomorrow it continues. And I will still travel maybe next tomorrow.
Next week. Wow.
Next tomorrow we go. Then state we are Tuesday. So enthalpy now is tabati ní any system tí flow ṣẹlẹ̀ tí ó ń flow ṣẹlẹ̀. So bí omi yẹn ṣe ń flow bọ̀ ó ní internal energy tiẹ̀. Ṣé understand me sir? Ó ní internal energy tiẹ̀ ó tún wá ní flow energy join mọ́.
Okay.
Okay sir, sorry sir. Nice. Okay sir. So bómi yẹn ṣe ń bọ̀ ó ní flow energy pẹ̀lú ẹ̀. So correct formula fún internal energy ṣé ń gbọ́ mi sir? It now be U plus PV.
Yes, U plus P.
Where plus PV. Plus PV. Where U is the internal energy tí mo explain lẹ́ẹ̀kan yẹn. Why PV component of it is the flow energy.
Okay, H equals to U plus PV.
That's H yẹn ni enthalpy.
Enthalpy,
It's not. It's not their fault, Jare. So U any internal energy, PV any flow energy. Along the line, when we begin to study about energy, you understand why PV is an energy. PV is actually energy, and it's actually energy due to movement, flow energy.
No, PV.
Yes, sir. Plus U plus PV. One low for one enthalpy.
Okay.
Share the example so I could lay in that. Tí o bá sí PV, yes, sir. Share PV. Internal energy nìkan la máa ní. That means the system is not moving. There's no flow. And that system is what we call closed system. But because the system is open, ó máa ní enthalpy because wọn kàn máa bọ̀ kò sí èyí sà omi tó fẹ́ wọnú táǹkì tí tẹ́ pumping machine pump ṣe àwọn fún example control volume tí mo lò fún open system. Ṣé àwọn kankan máa bọ̀ nǹkan kan push ẹ̀ bọ̀. Nǹkan máa gbé internal energy ẹnìkan bọ̀ ẹnìkan náà tún ràn lọ́wọ́ láti push ẹ̀. So combination energy tó máa add sínú system òun ni both flow and internal energy tiẹ̀. Kò sí èyí báyìí sà. It's totally different from just internal energy. So it has also flow energy with it. And that's what we call enthalpy. These are the 6 thermodynamic properties. They are divided by mass. We have form something called specific internal energy.
Energy specific.
Internal energy. So, things to explain, then you can call it today for tonight. So next time, Mama say state properties, parts, and state function, part functions, and all those jabberjanties that will make movement. Okay, sir.
Okay.
So yeah, we have something called intrinsic properties and extrinsic property.
Yeah.
So, tí gbogbo inú ilé ìbá jẹ́ 20 degrees Celsius, for example, lẹ́wà sọ pé here tó wà bí ó jẹ́ 20, here tó wà bí ó jẹ́ 20, here tó wà bí 20 degrees, 20 degrees. Tẹ́ bá gbogbo ẹ̀ papọ̀, ṣe àpò lè fún wa ní 200 degrees Celsius.
Yeah.
But ṣé temperature tí inú ilé wa ṣe 200 ní tòótọ́? 20. That means some properties tẹ́ bá add wọn together, wọ́n máa fún yín the same value. She understand that?
Okay.
And that is for what? Such property is what we call intrinsic properties.
Intrinsic property.
Intrinsic property.
Property of whatever had
the same value is what we call intrinsic property. Mass is not intrinsic. Because 20 kg plus 10 kg plus 5 kg, for any big number.
Yeah.
So,
temperature is intrinsic in it.
So intrinsic in temperature, pressure intrinsic in it. If I take the pressure, we can take the pressure, we can take the pressure, we can take the pressure. You can
The same thing. Okay.
Now, but kò rí bẹ́ẹ̀ fún enthalpy, kò rí bẹ́ẹ̀ fún volume. Tẹ́ bá take volume, take volume. Later the bigger volume, lẹ máa get.
Yeah.
So in a bit láti ṣé wá rí intrinsic property yìí, extrinsic, táwọn tó máa hard tó máa fún yín bigger number yìí, wọn ṣe é lò fún thermodynamics analysis. Ṣé ti understand báyìí? So that the next time I explain why they are not usable.
Okay.
So in a bit láti convert the extrinsic property to intrinsic property, we will now be dividing it by mass. One ló lead wa sí specific internal energy, specific enthalpy, specific entropy. Ṣé ti understand báyìí? Which is extrinsic property divided by mass will give us the intrinsic property, and the intrinsic property will not be called specific.
With what?
One máa fi specific síwájú ẹ̀, specific internal energy, specific this, specific that.
Divided by mass.
Mass.
Abi?
So what ó ti máa call the extrinsic, it will now become an intrinsic property. This is how we do all this stuff.
Oh yeah. Okay.
So now I really like it. If you can go through chapter 1 of any thermodynamics textbook, you actually explain all this stuff, talk about it. So
okay.
Sometimes we look into extrinsic more better. Mathematics just to prove it that the moment you divide by mass, sum will the same value.
Same value. Okay.
Yes, it's true. To give us the same value. The moment we divide it by mass, we give us the same value. And that's the interesting part. Because irrespective of how big a system is not our problem in thermodynamics.
Yeah.
We want something that will not change with the volume. Something that will not change with how big the system is. So that play the kekere, test here. Allow one intrinsic property, play now mafu. The same thing I test because property will change by size. You understand that?
Yeah.
So I help you to big thermal reservoir. Thermal reservoir to create tableau intrinsic property nígbà tá à ń ṣe analysis wa. Ẹ bá àti gbogbo ayé ṣe thermal reservoir ó sì máa work. Because the property was not based on the volume of the system. Instead of the volume was specific volume.
Yeah,
because that's the volume will not change irrespective of the size of the reservoir. So these are very important, and this thing also has problem with fluid mechanics, something we call dimensionless ratio, dimensionless number. These are what you find in that. So I believe the introduction part to some extent has been done.
Yeah.
So I try check one meters.
Yes, my
all right.
But video my family did again.
But only my dollar look ready. Only my dollar. I might be busy working on something I need to work on. See, tomorrow the royal Sunday or Monday.
Okay.
Sunday I'll be Monday. I should be able to just open Monday. I should be able to
okay.
Because now, but to my class, you also automatically recorded.
Okay.
But to make it available to you is what we take.
Okay.
All right, so yes.
So next time, next time, Abi. But you must go through. Go through now.
Go through. I'll share Monday. I'll share Tuesday. You understand? But for now, Sunday, my visit flight is Sunday.
Okay. Monday or Tuesday. Okay.
So share one teach that.
Where? That's my work. Also too early. Too early for now.
Abiola.
Yes, Abiola, yeah.
Where was the and I bought your ṣe lágbára Jésù.
Àmín.
Lára wà lọ gbogbo wàhálà ìlú tí ó pọ̀ lọ.
Àbí ó pọ̀.
I just wish that somebody just finds somebody that is not giving trouble. No trouble.
Yeah.
Àwọn obìnrin bẹ́ẹ̀ náà kú sí wà láyé. Ọlọ́run ṣàánú.
Wọ́n wà ọlọ́dọ̀kan ló kàn mọ̀ wọ́n. Wọ́n wà.
Ẹ wo, ayé ìjẹsà. Ayọ̀ ní ọjà sí ọgbà Ọlọ́run sàn.
Àmì o.
Ṣé kan ní ṣá o?
Alright.
Ó dàbọ̀ ṣá o.
Ok, o ṣé gan Ṣẹ́gun. Màá gbó kẹ̀ bí mo ṣe sọ, o ṣé gan. O dúpẹ́ lọ́wọ́ ẹ̀, o ṣé.
Yes, ìyàwó kan. Yes.
Alright.
Yes.